All right, so we're quickly gonna go through the biosynthesis of estrogens, right? So the first thing you need to do is we're gonna draw the general structure, and I'll show you how it works for all of them, right? So we're gonna have it's a six ring, six, then you just go like up again, right? Then you do five. So it's three rings of six, then one of five. Then you're gonna do the first row, which is like uh three molecules long, three compounds, sorry, long. And we're just gonna do that quickly. Then five. We do the last one. Six, six, and go up six, then five. Second row also has three. We do that as well. Same thing. Do that as well. Go up six, then five. There we do that as well. Should have drawn these beforehand. Six, up, then five. The last one has two, right? So lucky for us. So we're gonna have this, that, up, six, then five. And the last one is here. Oops. Let's do that, then five. You forgive the structure. Okay, cool. So the first thing we do is that you need to understand that this is a ring A, B, C, D. So that's how I'll refer to them, right? And the numbering will work on it. So cool. So now the first thing you need to do is make sure that between ring C and D, you put a CH3 group, right? So we're gonna do that for all of them. H3C, 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 H3C for each and every one of them between C and D, right? H3C. Cool. Now, the second thing which we're gonna do is we're gonna make sure that all the compounds on the bottom margin, they're gonna have an OH at position 17, right? So we start. This is position 17. So position 17 is the one on the five ring on the top part. So here it is. We're gonna have an OH group, right? On the ones at the bottom, right? So now everything else on that position, you're gonna put a double bonded oxygen, right? On all the other structures. Double bond oxygen, double bonded oxygen, double bonded oxygen, right? Making progress, right? So cool. Also, you need to understand that these ones here, right, are all aromatic rings, right? Will all contain an aromatic ring. So we're gonna put that aromatic ring there with its OH. We're gonna make it nice there. Another one there. Right, cool. And these are the only three which have an aromatic ring, right? So then what that means is that all of them, to change from something else to the one which contains an aromatic ring, there must be aromatase, right? So cool. So it means we know that one of the substituents already is aromatase. And this is not changing, so it's not from this one to this one. We will have aromatase. Doesn't mean it's the only one there. We'll just add as we go. We'll have aromatase, right? So what happens to the others, right? So for ring A, for the others, there's a general thing which I do is that from on the far left, it's gonna be we're gonna have an OH double bonded oxygen on position 3, right? So it's gonna be OH double bonded oxygen, double bonded oxygen. And on the top margin, it's the opposite, right? Instead of OH double bond, it's gonna be OH, OH, then double bonded oxygen, right? Cool. So Another thing which you need to know is that wherever there's an aromatic ring, right, there is no CH3 between ring A and B. So on all the others which don't contain an aromatic ring, we're gonna put a CH3 between ring A and B. So we do that here, we do that here, we do that here, we do that here, we do it here as well. Cool. So a cool thing that you need to know is that wherever we put an OH, right, on 17, it means that there was 17 OH SDH. It was involved there. Whenever we're changing from a double bonded oxygen to an OH on 17. So it means even here, we had what? We had 17 OH SDH. And where else again? All right. We also had it from here to here. So from here to here, we know we're going to have 17 OH SDH, right? And these ones are interchangeable, right? Where else? Here we have double bonded oxygen changing to an OH. So it means that we're going to have 17 OH SDH involved as well. This one is also interchangeable, right? Then, whenever we see an OH move to a double bonded oxygen, it means on the position 3, it means that we had what? We had 3 beta OH SDH involved. So now we're going to look. OH to this, okay, it was involved. It's double bonded oxygen, double bond, it wasn't involved. OH to OH, it wasn't involved. OH double bonded this, it wasn't involved, right? So we're going to have what? 3 beta OH SDH, right? So now we're very close, right? So there's also something else which you need to know is that on the furthest side, on the right side, like these two compounds here, the compounds on the furthest right will have what? Will have an OH on position 16, right? So they'll have an OH on position 16. And also, they form a triangle. You see, below we have the triangle of aromatic rings, and right in the corner, we have a triangle of those which have OH on the 16th position, right? So, now, whenever we find an OH on position 16 from a compound which did not have it there, it means that we had what? We had 16 alpha OHAs, right? So now we search for everywhere where there wasn't an OH on 16. So from here to here, you can see there's no OH here and there is an OH there. So it means that there was 16 alpha OHAs involved, right? Cool. We look elsewhere. From here, there was an OH and there was an OH, so it wasn't involved. OH to OH, it wasn't involved. Here, there was no OH, but it is here now. So it means that 16 alpha OHAs was involved, right? And now we're getting to the very last step, right? So this one's very simple. So whenever you see an OH on position 3, right, it means that of ring A, it means that we're going to have a double bond on ring B on the left side, right? So we're going to have a double bond here on ring B. So there's an OH there, there's an OH. So on ring B, we're going to have it here. Then also here there's no other OH which is not an aromatic ring. That's the important part. If there's an aromatic ring, obviously you won't have a single one there. You won't even have it here. Right, cool. Now, when there's a double bond, we're gonna have one on the ring A, right? So we're gonna put it here, and is there another one? Here's another one here. There's a double bonded oxygen on ring A, so we're gonna put a double bond there between 4 and 5, right? So let me just look at these structures. I think that should be everything, and it should have everything that you want and all the substituents. And that's how it, I kind of like summarize it and draw all of them. So with the naming, we can do the naming, but just as long as if you know the structures and you know that, okay, like for this one, for example, we look at on 17 and 3. 17 and 3. So there's an OH, there's an OH. So it's gonna be a diol. Things like that, you know. If there's a carbonyl on 17, a carbonyl on 3, it's gonna be dione, stuff like that, you know, not always applicable, but as long as if you know how to draw all these structures. Cool.